Welcome to Learning Monkey. I am Raghu here. In this class, we will try to understand how to find the inverse of an element using Euclidean, extended Euclidean algorithm. In our last class, we clearly discussed about what is multiplicative inverse and how multiplicative inverse is used in cryptography. Please watch that class and come back here. The link for the playlist is provided in the description below. Coming to today's class, this is the example which we used in our last class, multiplicative inverse. Z26 means set of all elements from 0 to 25, and we are going to use multiplication modulo operation. There we have discussed that these points we already discussed in our last class. Multiplicative inverse exists for only few elements. Every element in the set does not contain multiplicative inverse. Only few elements will contain multiplicative inverse. Which elements will contain multiplicative inverse? Inverse of 11, is it exist? Yes, it exists. When it is going to exist? GCD of our mod 26, right? GCD of 26 comma 11, if it is 1, then inverse element exists. Otherwise it won't exist. These points we discussed in our previous class. Now, inverse of 11 is 19. But in order to identify what's the inverse of 11 means, you have to check with 11 multiplied by 1, 11 multiplied by 2, 11 multiplied by 3, 11 multiplied by 4, modulus 26. Like that you have to check everything. Then we are going to identify which one is matching as inverse. This is what we have to do if we want to find the inverse element. But this is very difficult if you are having a Z260. Is it possible to identify the inverse element? You need to check all the values one by one. 260 Z multiplied by something. It is difficult, but using extended Euclidean algorithm, you can easily identify the inverse element for 11. Not only 11, you take any element, if the GCD value is 1, then it is easy to identify the inverse element. Now let's try to understand how we are going to use extended Euclidean algorithm and finding the inverse element with an example. But the logic behind this, why it is going to work, will be discussed at the end of the class. First try to understand the example. So here the elements are 26 comma 11. We consider 26 as A and 11 as B. GCD of 26 comma 11, this can be written as S multiplied by A plus T multiplied by B. This is what extended Euclidean algorithm means. Hope you already know what extended algorithm means. So now 26 is taken as x1, 11 is considered as x2. Now we are going to identify the GCD value. In that process, we are going to identify the T value also. So T1, T2 initially considered as 0 comma 1, x1 is 26, x2 is 11. So how we are going to find the GCD of value? 11 2's, this is the quotient value, Q means 11 2's 22, remainder is 4. Similarly, 1 2's 2, 0 minus 2, which is minus 2, remainder is minus 2. Now 11 will become x1, 4 will become x2. Similarly, 1 will become t1, minus 2 will become t2. Again repeat the process. We are not explaining again what is this extended Euclidean algorithm. Here S value is not needed. This term is not needed. S is not needed. Only T is needed. Why T is needed, why S is not needed will be discussed at the end of the class. Now if you do the entire process, repeat this process until you got the remainder value is 0. Once you got remainder 0, now x1 is 1, 0 will become x2. This is what the GCD value. GCD of 26 comma 11 is 1. If it is 1, then take T as, this is the T value, T as inverse element. But here T as minus 7. Minus 7 modulus 26 is 19. So our inverse element is 19. Inverse of 11 is 19. So by using extended Euclidean algorithm method, we are going to identify the inverse element. So inverse of 11 in Z26 is 19 is the inverse element. So hope you understand how we find the inverse element, why this extended Euclidean algorithm works for finding the inverse elements. Let's try to understand that logic. So if you take GCD of 26, 11 is equal to, this can be written as S multiplied by A plus T multiplied by B. Here A is 26, B is 11. GCD of 26, 11 is equal to 1. Then only this works. Because inverse element exists only if GCD of 26, 11 is 1. So if it is 1 equal to S multiplied by, in place of A substitute 26, in place of B substitute 11. Now apply modulus on both sides, because our operation is multiplication modulo. That's why we are going with mod on both sides. 1 modulus 26 is equal to S multiplied by 26 mod 26 plus T multiplied by 11 mod 26. This value is 0. Why it is 0? 26 multiplied by something, some constant, which is multiples of 26. Multiples of 26 modulus 26 is 0. That's why this S term here, S term, we are not considering the S term because it is going to 0. So this value is 0. Now remaining is 0. The remaining is this one. 1 modulus 26 is equal to T multiplied by 11 mod 26. Yeah, this is what, by looking at this, 1 mod 26 is 1 equal to T multiplied by 11 mod 26. What is inverse of 11 means? 11 multiplied by something, some number, modulus 26. If it is giving 1, then T is called as inverse of 11. That is what inverse means. Because 1 is the identity element for multiplicative inverse, multiplication modulo. So that's why T means this one is the T value. That's why our extended Euclidean algorithm is used to find the inverse of the elements in multiplication modulo. Hope you understand how we are going to identify the inverse element using extended Euclidean. If you have any questions regarding the concept, please post your questions in the comment section below. Thanks for watching. If you haven't subscribed to our channel, please subscribe to our channel and press bell icon for the latest updates. Thank you.